binary operation star on R cross R, that is on R in short, such that, let me define here, A star B is defined as A minus B modulus. That is the first one. And the second binary operation denoted by O, again on R cross R, or in short I write R, is defined as AOB is A, the first element. Okay. Now we have to prove. Let me take one by one. In the first part, I have to prove that star is commutative but not associative. So let me prove star is commutative. So A star B, as per definition, is modulus of A minus B, which may be written as modulus of, take minus common out of A minus B, you get modulus of minus times B minus A. And modulus of negative A is same as modulus of A, so it will be same as modulus of B minus A, and which is nothing but B star A. So I have proved A star B equal to B star A, and hence the binary operation star is commutative. And now let me check the associative property for this binary operation star. That means I have to check A star B star C whether it is equal to A star B star C or not. So take left hand side. A star B star C. Now what is A star B? Modulus of A minus B star C will be what? Modulus of modulus A minus B minus C. This is your left hand side. And now take right hand side for associative property, that is A star B star C. It will be A star modulus B minus C, which will be A minus modulus B minus C whole modulus. So what do you find from these two? These two are clearly not equal. These two are clearly not equal. Shall I take an example and check? Okay, suppose I take the numbers 2, 3 and 5. What will happen to the left hand side? See, 2 minus 3 is minus 1, modulus is 1. So you get 1 and minus, I have taken the numbers 2, 3, 5. So 2 minus 3 is minus 1, modulus is 1, and minus 5 is minus 4, modulus is 4. So left hand side will be 4. Now check the right hand side. That is 2 minus modulus of 3 minus 5. 3 minus 5 is minus 2. Minus 2 modulus is 2. And 2 minus 2 you get 0. So you see with the help of example also that the two sides are not equal. So let me conclude that the binary operation star is not associative. And that's what we have to prove in the first part. That is, the binary operation star is commutative but not associative. Now take the next part. Next we have to prove just the converse kind. That is, this binary operation O is not commutative but associative. So let me first of all, for O, for the binary operation O on R cross R, let me check commutative. That is AOB. How AOB is defined? AOB is defined as A. Just check up with the definition. The first element. AOB is A, the first element. And what is BOA? What is the first element here? B. So obviously, if A and B are two different real numbers, then A is not equal to B. Implies AOB is not equal to BOA. Or in other words, the binary operation O is not commutative. So that is one part. And now to check the associative property for the binary operation O. That means I have to check AOB OC whether it is equal or not to AOBOC. Take left hand side. AOBOC. AOB is A, the first element. OC. Now out of AOC, what is the first element? A. So on the left hand side you get A. Now take the right hand side. That is AOBBOC. AOBOC. Now AO and BOC means first element out of B and C is B. So again you get AOB. What is the first element? A. So from these two you find that finally for both we get A only. So we can conclude that yes, AOBOC is same as AOBOC, or in other words the binary operation O is associated. Or shall I conclude that the binary operation O is not commutative but associative? That is the second part. And now in the third part we have to prove that star distributes O. Star distributes O. What do you mean by this? That is A star BOC is same as A star B O A star C. Shall I give you a simple example for this? Like for example, do you know what is ordinarily for multiplication addition? A into B plus C. Do you know the distributive property? A times B plus C is what? AB plus AC. It is of the same kind. A times BOC is AB, that is A star B, and O as if it were plus. That's what you mean by distributive property. So this time we have to prove it. Not actually, this is not to prove. I've just given you an example. So to prove it, let me take left hand side. A star BOC. First of all, what do you say about BOC? The first element, that is B. And what is A star B then? Modulus of A minus B. So your left hand side is this. Now take right hand side. Right hand side is A star B O A star C. Now A star B is what? Modulus of A minus B. O A star C is what? Modulus of A minus C. Now the operation O between these two elements means what? The first element. What is the first element? A minus B modulus. So what do you find from these two? That in either case you get A minus B modulus, and hence we can say the star operation star distributes the operation O. So this is the third part. And now finally we have to prove the fourth part. He says whether O distributes star or not. So finally we have to check whether O distributes star or not. Or in other words, I have to check AO B star C whether it is equal to AOB star AOC or not. Okay. So take left hand side. AOB star C. Now when you take AOB star C, so what is the first element in this? Whatever B star C may be, the first element is A, so you get A. And now you take the right hand side. On right hand side you have AOB star AOC. So what is AOB means? The first element of AOB is A star. What is the first element of, sorry, it is O. What is the first element of AOC? It is A again. And what is now A star A? A star A, what is A star B? A minus B modulus. So here A star A will be A minus A modulus, that is clearly 0. So on one side you get A, other side you get 0. Obviously the two are not equal. So we conclude that the binary operation O does not distribute star. So that is it.